Okay, I'm going to do a quick thing on dependent systems. And dependent systems, I think, mean, they mean you get, I think I'm right when I say this, but I know that I'll be right when I get to the problem you have to deal with, that you get one solution or infinite numbers of solutions. I might not be right, but I think I'm wrong about that first thing. I think you get infinite number of solutions. But I'm going to give you an example that is going to be a simpler example than what you have for a dependent system. But the result's going to be the same. So look what's going to happen. We're going to try to solve this thing, and you'll see where we're going to get to. If I say I want to get rid of x, say, I'm going to use these two equations and get rid of x, and then I'm going to use 1 and 3 and get rid of x. So I'm going to use 1 and 2 to get rid of x, and then I'm going to use 1 and 3 to get rid of x. And I might say I'm going to multiply the first equation by -2. And in the second equation, I'm going to leave that alone, because I'm just trying to get rid of x. And that's going to, by multiplying the first equation by -2, I'm going to get rid of x. But look what happens. I get 0 equals 0. Well, that's always true. No matter what the particular values of x, y, and z are. Now I'm going to try to get rid of x using 1 and 3. And if I multiply the first equation by -3 to get -6x, I'll get -3y equals -6x minus 12z. They can make it less apparent by not lining things up the same way I line things up here. So I multiplied the first equation by -3, and I left the third equation the same. And in both cases, I got 0 equals 0. Well, that's always true, and that says that the equations are basically the same, and I get an infinite number of solutions. Now, because I have enough time, I'm going to erase all that stuff, and I'm going to talk about when you get an inconsistent system. And what I'm going to do here, Jay, is I'm going to again sort of simplify the thinking process so that I can easily write an example and solve it, and you'll be able to see what happens as I try to solve it. I'm going to say y equals 2x plus z plus 3. I'm going to say y equals, I think this is going to work, 2x plus z plus 4. They're almost the same equations, but not quite. And y equals 2x plus z plus 5. This is going to be inconsistent, because if I say I'm going to subtract the second equation from the first, in these two equations, I'm going to get 0 equals 0 plus 0, and I'm subtracting 4 from 3 minus 1, and that gives me 0 equals negative 1. Well, that's inconsistent, because 0 doesn't equal negative 1. Now I'm going to do the first and the... Well, right now I know that it's an inconsistent system of equations. Because 0 doesn't equal negative 1, so that's not consistent. But I'll still do 0... I'll still do 1 minus 3, equation 1 minus 3, and I'm going to get 0, because I'm subtracting the third equation from the first, equals 0. And again, they're going to make it a little harder to see at first glance, but when you do the work, you're going to get an inconsistency. Here, 0 doesn't equal negative 2. So those are those. I think that is enough for you to do everything, Ajay. And if you want to send me stuff, I still haven't eaten dinner tonight and whatever, but I'll probably be able to respond tonight. And that should help you to solve stuff for when I see you tomorrow morning. Okay, thanks.